So I'm going to walk you through partner problem 2 since we didn't have time to do that in class today. So partner problem 2, you should have a printed copy of it, so I'm not going to read it back to you. You can take a moment to read it now. Okay, so what I want to do is follow through the steps. And the first step was write the variables and what they mean. So in this problem, you have a theta, which is an angle in radians. And then you have that this is in a right triangle, and you have x and y are the lengths of the sides adjacent and opposite, so they're the two legs. And x is the adjacent. And the units are in, just says units. And then y is the length of the opposite leg in units. Okay? So we're told that this is happening. I'm going to go ahead and draw a picture because it actually helps me to kind of keep all this stuff organized. So this is a right triangle, and theta is an angle in the right triangle. I'm going to pick it to be that one. X is the length of the adjacent leg, and y is the length of the opposite leg. Cool. So step 2 is to find the rates of change, both known and unknown. So if you're reading through the problem, you see that they tell you that x is increasing at 1 unit per second. So increasing at 1 unit per second means there'll be a positive rate of change. And since it's x changing with respect to time, that's dx dt. They also tell you that y is decreasing at a rate of 1/4 of a unit per second. So that rate of change would be 1/4, but negative because it's decreasing unit per second. And since that's y changing with respect to time, this is dy dt. And they ask you to find how fast theta is changing. So they want you to find d theta dt when, let's see, what's the instant? It says that x equals 2 units and y equals 2 units. All right, so that's step 2. We've got the rates of change and the ones we know and the ones that we don't. So step 3 is draw a picture. I've already done that. And to find an equation that relates the variables that you did in step 1. So I have these rates of change. I have these variables. So I want to relate theta, x, and y. So when you're relating an angle in sides in a right triangle, that's SOHCAHTOA. So I have here tangent of theta, and I chose tangent because y and x are opposite and adjacent sides, equals y divided by x. Now, I want to note that these things are all dependent upon time. So this is tangent of theta of t, and this is y of t divided by x of t. So now I have an equation that relates these things and I have it in terms of time. So I'm going to move on to step 4, which is taking the derivative of this equation with respect to time. So when I do this, it's going to be chain rule on the left and quotient rule with chain rule on the right. Now, if you need this, you could write all this out. I'm simply going to take the derivative and you can sort of check my work on your own. But the derivative of the left-hand side, the derivative of tangent, is secant squared. You leave the theta of t alone, and then multiply by the derivative of both the side, which is theta prime of t. And then on the right-hand side, it's quotient rule, which is low, d high minus high, d low, over low. Now, the derivative has been taken. I'm going to switch it back to Leibniz notation. And that takes us through step 4. Now we're at step 5, where we're ready to plug in everything we know. So I know dx dt, dy dt, x, and y are the instant that I'm working with. So I don't know theta unless Well, I will know it, but we'll talk about that in a second. d theta to dt is what I'm looking for. X was 2, dy dt is negative 1/4, minus y, which was 3, times dx dt, which was positive 1, all over x squared, which was 2 squared. So now, all this stuff over here on the right is just a number. It's negative 1/2 minus 3, which is negative 7/2 over 4, which is negative 7/8. Hopefully I did that arithmetic right. You can check me. Now I need to know what secant squared of theta is. Now there's a couple of different ways you can do this, but I'm going to do it by going back to the information we know about the situation right now. At the instant, we're trying to find the rate of change, where x is 2 and y is 2. Oh, come on. Don't give me trouble now. Good enough. I'll make it a 2. There we go. So if I wanted to take the secant of that angle right there, then secant is the reciprocal of cosine, and cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent, so I would need the hypotenuse of this triangle, which, if my calculations are right, would be the square root of 8. And then I want to find the secant of that and square it. So the secant of that would be hypotenuse over adjacent, square root of 8 over 2 squared. And when you square that, you get 8 over 4, which is 2. So my d theta dt is negative 14 over, negative 7/16. Now, this is a rate of change, and we need to put the units on it as well. So when I put the units on it, t is going to be whatever time we're dealing with in this problem, which was seconds, but the angle for theta is going to always, always, always be radians. And we can talk more about that in class, but that's always going to be true. So basically, this is the answer to that question, if I remember what it was asking at this point. And this indicates that the angle is actually shrinking as the problem goes by.